So I want to teach you guys to do determinants of slightly bigger matrices. So we'll start with 3 by 3, then we'll maybe do 4 by 4, and then you can figure the rest out. They're not different. Okay? So first things first, I recommend that you start by writing down an alternating series of plus and minuses across the top row. So plus, minus, plus.
Why?
Trust me.
You'll see.
This is not a why thing. This is a magic thing for right now. There are very few things in math that I'm going to say are magic. This one's magic for the moment.
Okay.
Trust me, this is a meaningful number. The why on this is really sort of deep, and I don't want to go there. So what you're going to do is you're going to say, okay, the determinant of this thing, which we're going to write as absolute value bars, because in some sense it is kind of the size of what's going on here, is, then write down your numbers with their associated signs. So your first number here is what?
Positive 1.
Positive 1? Okay, so 1.
-2.
Leave yourself a bit of space, -2. Leave yourself a bit of space, and what's the last one?
0.
0. Plus 0. What?
Nothing.
Okay.
We'll chime in later.
Cool. All right, now what you get to do is this space here is going to be filled in with the determinant of a matrix. That matrix is going to be smaller than the one you started with. And the way you get it is you find the number 1 that you were talking about. That's my top left number. And I'm going to cover up the row and the column that that number's in. And then I'm going to write that little matrix down next to the 1 with absolute value bars. I'm going to say absolute value of 0, 1. Oops. Let's try the right matrix, Jeff. So I wrote down 1, 1, 0, 1 in that space. Okay? Now, next to the 2, what are you going to do?
You'll cover up the row.
Cover the row and the column.
0, 1.
So that looks like 0, 1, 0, 1. And then you'll have plus 0 times
0, 1, 0, 0.
that one's got lots of zeros in it. Okay. And I'm going to keep playing with that one even though it's obviously not going to contribute anything. You guys all good with that?
That's good.
Basically, I just want to give you another little piece of example. All right. Next step. Equals what? You know how to do these?
Yeah.
Determinant of this little guy. So that's 1 times do this multiplication minus that one. 1 times 1 minus 0 times 1.
You chose a really easy one.
I know. I was going for easy right now. We'll do horrible next. Okay, see that? How is this multiplication minus that one?
Then where'd that second times 1 come from?
This guy?
Oh, no, I see it, never mind. I
Okay.
was a little confused. Yeah.
Then I've got minus 2. And now I need to do the determinant of this little guy. So that's
0
the
minus.
diagonal, 0 times 1, minus the anti-diagonal, also 0 times 1. You guys cool with that? Then we're going to add 0 times, what do I get out of that?
0.
0 times 0 minus 0 times 1.
So I got 0 times 0 minus 0 times 1. Okay, so this piece is 0. Right, because it was 0 times some stuff. This piece
0.
is 0 minus 0 is 0. And this piece gives you, oh, that one's 0.
And then 1 times 1 is.
So I think I got 1 times 1 times 1 is 1. Okay, what does that mean?
The determinant of that matrix is 1.
Okay, I did a calculation, right? The determinant of this matrix I started with is 1. What information can I glean from this?
That the area that it multiplies any object by is 1.
Yeah, totally.
It's
As a
equal.
function, this thing doesn't expand or contract area in 3 dimensions. Okay, beyond that, maybe slightly advanced explanation. Specifically, this thing's going to have an inverse. Okay, see that? This function is going to have an unfunction. Meaning I'm going to be able to come up with a way to undo this thing because the determinant wasn't 0. So right now of interest to us is specifically that 1 is not 0. Guys okay with that?